Welcome to another exciting edition of Comet Algebra. These are the notes for section 9.2, multiplying and dividing rational expressions. So first, to start off with a quick review of what you already know. When you multiply fractions, 2/3 times 5/7, you multiply straight across. 2 times 5 is 10, 3 times 7 is 21. Then reduce if possible. Okay, quick review for dividing fractions. When you have 2/5 divided by 3/5, we actually do not divide fractions because mathematically it's the same as multiplying by the reciprocal. So we're going to use this exact same strategy even if the fractions are loaded up with x's and y's. You can cancel up and down. You can cancel diagonally because canceling is dividing. So these two 5's could cancel out to be 1's, and we're left with 2/3. So keep these strategies in mind now. So here in this first example, we're multiplying these two rational expressions, and we can cancel up and down. We can cancel diagonally because canceling is dividing, and we have a ton of canceling in this problem. So first, looking at the I see a 5 and the 20, so 5 goes into itself once, 5 goes into 20 4 times. With the 3 goes into itself once, 3 goes into 27 9 times. So we have the numeric part done with the 9 and the 4. So now let's look at the x's and y's. These two x squareds divide away to 1. This y takes out one of these y's, so I still have this y left. I'm just going to draw a box around it so I don't lose it. That's the only thing that's left over here in this fraction. Over here, this x cancels out one of these, and this y takes out one of these, so I'm left with the y squared. So just for clarifying, let's try to write down what we have left. In this numerator, we have an xy squared, so I'm going to write that down. Nothing in this denominator, nothing in this numerator, but I have a y in that second denominator left. So we can still do a little bit more canceling. This y takes out one of these. So my final simplified answer is 9xy over 4. In this next example, we're multiplying these two fractions, so there's no reciprocals to worry about. We simply need to factor everything, cancel what we can to simplify them. So kind of just looking across here, I'm just checking for any GCFs in any of these, and I am not seeing any. These look like all 4 of them would be diamond box problem or guess and check, depending on your preference. So I guess I'm going to try this first one with guessing and checking. Again, your preference. So if I have 3x and x, I need to figure out how to get a 7 out of this. So if I have to get the -6, I could try the 2 and the 3, and I'm planning ahead a little bit here. If I put the 2 here and the 3 here, and I need the 6 to be negative, if this, I'm looking ahead, 3x times 3 is 9. 9 take away 2 would be 7. So I need this 2 to be negative and the 3 positive. And again, if you do not like guess and check, go ahead and diamond box it. So with the denominator, I need a 2x and an x. I need to multiply to get -3 and add to get +5. So with the 2 times, if I put the 3 here, I'm going to get a +6x. And if I put the -1 here, again, I'm just showing you I'm checking my inner and outer product. Here's a -x, here's a +6x, and that does indeed add up to the 5x. So this denominator is good factoring wise. Now let's keep factoring the rest of these. Now factoring this second fraction, I talked about in class how you can look for clues in these problems. And a clue that I'm seeing here, in this first fraction, we have a 2x minus 1 factor. Now, it is very likely that we're going to have a lot of canceling. So when I look at this second numerator and I see the 2x squared, I'm going to take a guess that perhaps one of these factors is 2x minus 1, because then I would be able to cancel it. I see this as a hint. So let's just check it. What have we got to lose? So if we finish this factoring, to get the 2x squared, we have to have an x here. And to get a plus 7, we would need a negative 7. So let's check our outer and inner product. This inner product is negative 1x. The outer product is negative 14x. And negative 14 and negative 1 does give me my negative 15. So that worked great. Let's use that same strategy here in the denominator. Let's look for clues in the problem. The clues would be found in looking at the factors that could possibly be canceled with this. So I see I have a 3x squared, and looking in the other numerator, they have a 3x minus 2. So I'm going to take a guess and check to see if that is a factor of this second denominator. 3x times x, of course, is 3x squared. And now let's check this negative 2. Negative 2 times a positive 5 would give me that negative 10. But now we have to check for the positive 13. The inner product is negative 2x. The outer product is 15x. And that indeed does add up to my 13x. So now everything is factored. The next step is to look for any canceling, and we have a lot of it. This x plus 3 cancels out this x plus 3, so those are 1s. This 2x minus 1 cancels this one. This 3x minus 2 cancels this one. So we are left with x minus 7 over x plus 5 as the simplified answer. This last example is a division problem, so we need to keep that in mind. We will be factoring everything, and then we will be multiplying by the reciprocal of the second fraction. So we got a lot of work to do to get this set up. Looking at this first numerator, we notice that we do have a GCF. So let's factor out, they all have a 2 and they all have a y in common. So if we factor that out, we end up with y squared plus y minus 6. Let's go ahead and keep factoring this numerator so we can get it all the way down to its factored form. Doing this one mentally, what multiplies to negative 6 but adds to 1, and I believe that would be a plus 3 and a minus 2. Okay, so now we have that first numerator completely factored. Let's factor this denominator. What multiplies to negative 5 but adds to positive 4, and I believe that would be y plus 5 and y minus 1. I'm just doing a quick FOIL. 5y minus 1y is 4y. So now in the second fraction, I am going to change this divide sign into a multiply sign. And then we are going to take the reciprocal of this second fraction. So let's do two things. Let's factor it and flip it around. So factoring the y squared minus 1, that is the difference of two perfect squares, y plus 1 and y minus 1. Factoring this, which is now going to be in the denominator, what multiplies to negative 6 but adds to a positive 1, we have y plus 3 and y minus 2. So just checking, 3y minus 2y is 1y. So now everything's factored. We have taken the reciprocal of the second one. If we were asked to the excluded values, this is where we would stop before we do any canceling and figure out what makes any of these denominators 0. So we have several excluded values here for this first factor. Y could not be negative 5. The second factor, y cannot be 1. For this third factor, y could not be negative 3. And the last factor, y cannot be 2. So we had this is all part of our answer, all 4 of these excluded values. So now let's go ahead and cancel what we can. We have y plus 3 here, cancels with this y plus 3. We have a y minus 2 canceling, and we have a y minus 1 canceling. So what we have left in our numerator is 2y times y plus 1, and the only thing left in the denominator is y plus 5. And that's completely simplified. Okay, we cannot cancel this y at all because this y is part of a binomial, and the factors are all or nothing for canceling. All right, now you have the knowledge you need for 9.2.